Hello. Can you hear me okay? I was wondering if anybody was going to show up today. Can you hear me okay? Okay, good. I'm glad you can hear me. Well, welcome to the week 6 office hours. I'm glad you joined. Hopefully, everybody will be joining shortly. Did you have trouble coming into the presentation or the session? Or did you get in okay, like normal? Well, it is time to start. Oh, here we go. More people are showing up. Good. Excuse me. There we go. Everybody's showing up. You're getting a late start, huh? Or actually, you're just on time. You're just not early like usual. Hello. Good to see you. Well, as everybody's joining us, I'm going to get started. Again, we'll start with the review for week 5. Again, we're getting into a lot more sophisticated or complex information now. Again, an operating system in general is very complex and very sophisticated. There are a lot of management strategies that need to be followed, need to be calculated. And you did see that during process management. Now we're talking about memory management. And being that you have a set fixed memory, you have to make sure that it's all managed correctly, and whatever processes need memory, it's allocated correctly. So there are a lot of strategies that you reviewed this week on the memory management. Week 5. This week we're going to be talking about virtual memory management, which is a way to supplement the hardware memory that you have existing on your computer. Usually there are other devices that are used to help supplement that memory, because again, our applications and our requirements these days for the usage of the computer involves a lot of resources. So the operating systems have to be clever into how they allocate all their resources and how they switch between, demanding processes or usage of the memory. And as we go further, we'll be talking about users, and also we'll be talking about devices. But any questions so far on week 5? We talked about memory management strategies. Each approach has its own advantages and disadvantages. Selection of a memory management method for a specific system depends on many factors, and one of them is the actual hardware, because it is the allocation of the hardware itself, the memory cells or the memory chips that are used. So the strategies then have to use carefully designed algorithms and carefully designed strategies. So a program, as we know, in order for a program to process, it's the CPU that processes the instructions, and the rest of the instructions or data are held in memory before the CPU is ready to process the next instruction. So memory management is critical, especially to multi-programming systems when you have multiple programs running, or if you have multi-processor systems. So various memory management algorithms are discussed, including contiguous allocation, paging, segmentation, combination of paging and segmentation. But in general, all of them have to make sure the memory addresses are generated. So do you have any questions so far on Chapter 5? There was a lot of information given. Here were the topics. Again, as you study for your exams, you would go over your topics, have a brief summary, and then I do offer you those questions as well. And I'll have questions now here. We'll go over the answers from week 5, and then I'll give you new questions for week 6. But any questions so far on any of these strategies? Okay, so you're pretty good, that you have a good understanding of them. Very well, very good. Okay, now are the examples important? Again, your exam is going to be multiple choice or true false. So going off of the type of questions that I give you to study from, that would be your understanding of it. So sometimes the examples help you understand it, but in order to answer the questions, you would then, look at the question. Again, the strategies are read the question very carefully and then read the answers very carefully. Usually there's one word or a keyword here in the question that kind of gives you an idea then what the answer will be. Okay, so all the assignments are graded. You all did a wonderful job on the answers, even the programming part. You gave me either a variety of pseudocode, a variety of Java code, some C code, some flow charts. So you all at least had the basic of the logic, and that's the most important. If you do have the time to actually program them and have output screens, some of you did do that. That's fantastic. That just also reinforces your programming skills. But it's the logic that was sufficient to meet the requirement for the answer. And if you took it farther, fantastic. You please do post. I'll have a thread again in the discussion forum for you to post what you did for your fellow classmates. And the programming assignment from week 4, you did discuss it. A lot of you put your flow charts and other material that you created for it, which was great to see. And also a couple of the programs that some of your classmates actually created were then posted for you to see them in case you want to, if you didn't get a chance to program it, you can take it to that next level. So that's up to you. But again, it's the logic that's important when it comes to answering the assignment. But if you want to program it, again, that's just for you. That'll just make you that much better of a programmer. So that's up to you. Okay, so any questions here on these exercises that we had for week 5? This kind of was a good refresher, and it kind of went over the various strategies here from contiguous memory allocation to pure segmentation and then paging. And as I gave, these are the answers. So a lot of you understood this. You did give me this very similar answers here, so I think this was some concepts that you were able to understand. This one has some calculation, but again, a lot of you did very well on this. You understood it. You actually gave me some mathematical type of equation as to how you figured out the answer. If you just Googled the question, you got a variety of web pages that had the answer as well and had additional explanations. So hopefully that helped you as well. So this was the first part of this exercise. And then for this one, some of you, there was 2 parts to this. You could be single level, which was the 128K entries. But then some of you gave the 124 entries, but that was for multi-level. So depending either one, I gave you credit for either one and just noted that there was a difference between the single level and the multiple level. So hopefully that was understandable. Again, a lot of you got this. You got the 217 physical pages even though the question was about how many entries into the table, not how many actual physical pages. So, but if you gave me the physical pages amount, that was fine. I gave you credit, but it was, again, read that question carefully. That'll be very important when you're taking your exams, because there is a difference here in the answer. 128K is different than 2 to the 17th. So depending on how you read the question determined if you got the correct answer as it was asked, even though both are information about, you know, what will occur and what is happening when you have this different scenarios. But make sure when you read your question carefully that you answered what is being asked. And then this one was, again, if you had a program or a flow chart or just pseudocode, all of that was accepted as long as you understood what was going on here. And all of you did. So again, you could have Googled this, and this was an example solution that was given in the programming language C. You're more than welcome. Again, some of you did do it in Java. Some of you just gave at least the classes and the code for it. Some of you actually ran it and gave screenshots for the output. So please feel free to share this with your classmates. And if you had any questions, there were some questions in the discussion forum that were answered as to what this code meant. Again, you had to make sure that you worked within the memory space that was given from the beginning to the end. You didn't go over, extend the boundaries of the memory allocation, and also that you were working with memory addresses. Addresses themselves have a specific number of, bits and bytes, and you had to make sure that whatever you returned had the correct amount. Because if it was used for later processing, then you got to make sure your numbers were correct. And the numbers that we're getting, you won't have any programs on the midterm exam, no. You'll have more of those multiple choice type questions than true false. You won't have to do a program. So that's just for you now, just to, in case you wanted to, know more, or if you like to program, then you can program it. So, yes, you won't have to worry about it. That's why I give you the extra multiple choice questions and true false questions to give you some study for the midterm exam. Okay, the mapping of a logical address to a physical address is done in the hardware by the MMU. All of these have the answers, so if you didn't get the answers or have a chance to explore these exercises, then here they are now with the answers. But the MMU, again, if you look at the section 8.1.3, you will see the picture of it and the actual strategy that is used with the MMU. Next question. In a dynamically linked library, a stub is included in the image for each library routine reference. This was like a placeholder. When you have dynamically linked libraries, it allows the code to be kept in the library, and later, after you compile your program, anything from the library is then put into your code when it's executing. Before that, it's just put in by a stub. Or that's similar to you when you do programming. You have like a code word, or you have a function, and then you just have the arguments for the function. But you don't have to include all the code that belongs to that function. That's held in the library. And later, after it compiles, it then goes through the linker, and then everything gets linked up before it executes. And that stub is just like a placeholder, similar to your keyword that you use when you use a particular function, and that it is in a library. And again, more information on that is 8.1.5. Okay, exercise 3. The blank binding scheme facilitates swapping. And that was execution time. Do you know the difference? There was the difference of when things, memory addresses were created. That was different between the load time or some, all these different times. So do make sure that you do know these points in execution, or the points in the process of when memory addresses are then created. Sometimes they're created right away. Sometimes it has to wait till the program is running until it's created. So do know the difference of what types of code or what types of instructions will allow you then to have memory or need memory addresses created right away, or if it could wait, or if it has to wait during the runtime. So it's loading time, compile time, execution time. So know the difference. And here we had various dynamic storage allocation algorithms: best fit, worst fit, first fit. And that, again, is where you had a strategy that would look to see what was available. Smallest leftover hole in memory was best fit. In other words, you see which one could fit the best in the amount of memory you have available. So again, the way memory was allocated depended if it's a set page or if it's segmentation. Segmentation had a variety of sizes. The page algorithm had a certain size that's allocated for every process. But what happens there is that if that whole page is not needed, then you have some wasted memory. So there was a lot of different strategies in how to do this, only because processes vary. They vary as to how much memory they need. And so we can't just make a straight amount for every process, because then it may be too little, it may be too much. So a lot of strategies had to be employed. And again, section 8.32 goes over the different strategies that were used. And this results in the largest leftover hole in memory, and that's the worst fit. In other words, you used a small requirement for a large amount that's given. So again, go over these questions. Here we go. This might be on the midterm exam. So consider a logical address of 18 bits used to represent an entry in a conventional page table. How many entries are in the conventional page table? And that's the answer. So again, go to section 8.5 and I'll give you actually, it'll draw out that algorithm and how it's calculated. Same thing here, section 8.5. It allows you then to know how to convert between the different addresses. And we did talk about the different numbering systems between decimal, hexadecimal, binary. Right away when you start seeing letters, you know that you are using the hexadecimal numbering system. So again, it's just a matter of mapping. And then here were some real examples of architectures that were used. And the ARM architecture uses both single-level, two-level paging. There's three-level paging. Again, it's all strategies into how to allocate this group of memory, the memory space that you have. It's a fixed amount. And then how do you then allocate it for the variety of sizes needed by different processes? Inverted page tables require each process to have its own page table, and that's false. This actually maps out the memory addresses rather than you have a table of the memory addresses, actual memory addresses, rather than the page tables and addresses, or your logical addresses. So inverted page tables has physical addresses rather than logical addresses. Again, here's another question. Why is this false? Does anybody know? We talked about one of our sizes. One of our exercises had something similar. Does anybody know why this is false? That's 1 million entries. One thing here, or one clue, is that the size of the entry itself you have to take into consideration. You also have to know what size you are needed, and then determine and do the division to determine how many you could actually have. 4 kilobytes, there you go. So again, if you want more information, go into section 8.5, and that'll break it down for you and actually give you some examples. Also, you can Google a lot of these questions, and then you'll get actually full presentations that'll give you more additional information. Okay, so that was week 5. Now we're going to go more into memory management, but this is specifics about virtual memory management because it is very popular and it is used very frequently. So virtual memory is a technique that enables mapping a large logical address space onto a smaller physical memory. So in other words, you're trying to do more with what you have with the strategies that you use. It makes it possible to run extremely large processes and to raise the degree of multi-programming with increased CPU utilization, even though a process's entire memory image is not in physical memory at once. So here you try to do some shuffling. Okay, maybe you don't need everything in memory at the same time because some of the, obviously everything is not going to be running in exactly the same time. It's got to do it in a sequential step, instruction by instruction, you know, depending on CPU, how many CPUs you have. And that kind of gives you an idea too of your critical section. We did talk a little bit about critical sections, and that comes into play here. If it's the critical section, yes, then that information needs to be in memory. But those areas that are not critical, they do not have to be in memory at the same time. And also when you talk again about your race conditions, you know, only part of it has to be done. We know there's an order. Something has to be done first before something else. But that means that that part that can wait, that doesn't need to be in memory either. So it's then dissecting further, knowing what needs to be immediately in memory and what can wait, and then we can use different types of storage devices or storage areas so that less memory at any one given time is needed. So the common implementation of virtual memory is by demand paging, where pages are loaded only when they're demanded during program execution. Prime example is the operating system itself. You have internal processes that are kept in memory at all times, but then you have external processes or external programs, those part of the operating systems that do not need to stay in memory so that you can use the computer. So some of it can stay out on the hard drive. And so that is called similar like demand. It's out on the hard drive until you need it. Then on demand, when you need it, then it will be loaded into memory. So again, it's a way of utilizing what memory you have to the most efficient way possible. So here are some virtual memory management strategies. Again, here's a list for you. You can briefly describe all these, and this will give you a good head start then, or as a study guide for when you study for your exams. These are your assignments. So you have your PowerPoints, you have your reading assignments. There's also an article. That article, again, you could discuss it in the discussion forum. It is not graded, but it is something you can read. Again, the more you know, knowledge is power. So even though you don't get a grade, it is something good for you to know. And then your videos. And then your assignments. You do have your exercises 9.9 and 9.12. You do have a programming project. Again, I will give you some information, but the same thing is, if you give me some flow chart or some pseudocode that talks about the logic that is used, That'll meet the requirements. If you want to go further and program it, please do. That'll give you extra skills. And also, it'll just make you that much a better programmer. And then we have the article response. Now, you can discuss the article in the discussion forum, but there is an actual place for you to post it in the grade book, even though you don't have any points awarded. You get 0 points, but it is a way for you then to just show what you did answer. So you want to maybe use that to keep a log. So whatever you would post in the discussion forum, make a copy of it and also post it in the grade book, just so something is there from everybody for this article response. Okay, so let's look at these questions. Here's exercise 9.9. Again, Wednesday we'll go over more material as to what we're covering, but as for right now, these are the questions. So the page table in figure 9.31, or the table that's shown here, is for a system with 16-bit virtual and physical addresses and with 4,096 byte pages. Reference bit is set to 1 when the pages have been referenced. Periodically, a thread zeroes out all values of the reference bit. A dash for a page frame indicates the page is not in memory. The page replacement algorithm is localized, LRU, and all numbers are provided in decimal. So this is just information then about the question, some background. And this is what you need to do. So this is the question. And again, we'll talk more about this on Wednesday, but here is just the exercise, then you can start preparing for it. And this is exercise 9.12 as well, something for you to prepare. And then your programming project. Again, you can actually do a regular Java program, or if some of you want to start learning C, C is very heavily used. C and C++ is used very heavily as a systems programmer because it has a good capacity to deal with hardware. So if you want to learn that, you're welcome to do that, or you want to get stronger with your Java, you can do that. Or you can just give the logic and the flow chart, and that'll work as well. And this is not an actual programming class, this is just understanding operating system concepts. So write a program that implements the FIFO, LRU, and optimal page replacement algorithms presented in this chapter. First, generate a random page reference string where page numbers range from 0 to 9. Apply the random page reference string to each algorithm and record the number of page faults incurred by each algorithm. Implement a replacement algorithm so that the number of page frames can vary from 1 to 7. Assume that demand paging is used. So these are kind of helpful hints as to how to go about and answering this program or this assignment. And this is further instructions as to how to complete this. So I think after you read the chapters more and you understand the material that's covered this week, you may want to revisit this if it's not making sense to you right now. It will after you view all the videos, do all your readings, and then concentrate on the section where this is covered. And here's, again, some example code for logic as to what is involved with this program. Again, here's some tips and steps to follow when you create this assignment. So you have something called a replacement algorithm. You have a page generator. You have some methods for the page generator because that's what you're going to be creating. And here's some additional links. Again, I will post these slides in the discussion forum so you can visit these. These are actual codes that answer this assignment question. So that'll be helpful for you. And then we have some additional exercises. So hopefully this will help you as well. So after you do your readings and view your videos, you can then go back and see if you know this, or just know the question ahead of time while you are reading, so that when you do find the answer, you know it right away and you can log it in. And you're welcome. Yes, you're welcome with the help that I offered and the links for the programming project. Again, it's the logic that's the most important. This is not a programming class, but obviously if you have the time to do the program, then you'll just be that much stronger as a systems programmer and understanding operating systems. But understanding the logic is important, more important than learning syntax, since this isn't an actual programming class. But whatever you have time for, whatever you want to do, works fine here. It all depends on how far you want to master your skills. And again, I will post in the discussion forum where you can collaborate on the program, and also where you can post your answers from the week 5 program, or mini program, which was one of the exercises. So again, collaborate with each other. If you have questions, ask each other. And if you do whatever you did create, or if you are working on the program, please feel free to then share it with your classmates. Again, we are all in this together. So we're going to be looking at various replacement algorithms as you read through the chapter. And again, here are just some questions to help strengthen your understanding of the material. So do that. We'll go over the questions. The answers will be given to you next week. But it's a lot of various topics that you can go through. So again, I'll post this in the discussion forum so that you can then have access to it and start working on the material. Any questions so far? Again, I did grade all your material. Most of you, you got full credit pretty much for the exercises in the program, as long as you offered at least the logic of the program and maybe some pseudocode or snippets of code which worked. Some of you actually did go through and offer some actual screenshots of the output because you had a full program. Good, I'm glad this is helping you. And again, it is week 6. In 2 weeks you will have a midterm exam, so it's a good time now, if you haven't, that you still review from week 1, week 2, and so forth. I would use all the questions that I've been giving you since week 1 to refresh your memory, and also those lists of the topics to help you refresh your memory. I know since we are already in week 6, it might be hard to remember what we talked about in week 1 or week 2, so hopefully you started generating some study guides for yourself. Again, you have these lists of topics that you can give yourself the answers. All the topics we covered all through week 7. So in week 7, we'll be doing, I believe, chapter 10 and 11. So I would say up through chapter 11. It may just be 10, but it might be 11. I don't know. I'm not in the classroom right now. So in week 7, whatever chapters are covered in week 7, then you will have all those chapters from week 1 through week 7 that are covered on the midterm exam in week 8. And again, I will give you some review study guides. I'll compile all the questions that we covered in all the topics and give you a review guide that I will go over. We can go over on week 8 office hours. So if you have questions, be ready to do those. When will you do for a review? Okay, we'll start, week 8. On office hours, we'll do the review, and we'll post information in the discussion forum. So you'll have all the material, what I was giving you and offering you. But of course, you should review your textbook readings. You want to review the videos. You want to go over the exercises as well. And again, go over all the exercises. Every chapter has a whole list. I'm giving you some questions that are similar to the questions on the exam, but also there's exercises at the end of the chapter, and these exercises do, again, cover all the material in the chapter. You are responsible for all the material in the chapters. Anything can be covered on the midterm exam. So hopefully that will help, yes? So we'll go over them in the week 8. And you have all these presentations. Go over the presentations I offer you, as well as review the recorded. All our sessions are recorded, so in case you want to listen to them again, feel free to do so. But it's all a matter of what it works for you when you study. But for sure, everything up through week 7 is included on the midterm exam. So if you haven't started creating some study guides for yourself, please do so. I will also be giving stuff for you in week 8 on the office hours. So any questions on anything? There's not much more for me to talk about, so if you don't have any questions, we can call it early. Good question. This is coming from both. There's a collaboration. But I can tell you right now, it's going to come from the test bank from the textbook. So, again, it's going to be similar to the multiple choice and true-false questions I am giving you. So it is material from the textbook. So that gives you a good guideline right there. So the topics, SEU. I guess your exams will be proctored, is that correct? You will have to show up for your exam and someone will be there to give you your exam. And they're the ones that are responsible for grading them. But it's going to be pretty objective. I mean, it's either you have the correct answer or you don't. It's either, it's going to be either A, B, C, or D, or true or false, and it's not a matter of maybe it's correct or maybe it's not correct or part of it's correct. It's either correct or not correct. So that's what I mean. Take your time when you read the questions carefully. Usually the answers are in the question. Or there's keywords in the question that kind of tell you right away what answers that might be the answer, what answer that won't. And then when you read the answer carefully, again, you will get some kind of a connection between the question and the answer. So just take your time. And then if you have time after you complete the exam, go back and check it to make sure you didn't miss something or you went too fast. But I know you all do well. And I think you're all smart that even if maybe you don't remember exactly everything, you'll be able to figure it out because you're smart. Okay, any more questions on that? Just a matter now of just you going and reading materials, watching the videos. I can give you, I'll give you a little extra time now. You can get started on the assignments and get into the discussion forum. And we can carry over then our discussion over there. So if you don't have any questions, then I'll call it a morning or an evening. Call it a session. Okay, wait, no, I see a lot of difference in what is being focused on among SEU branches. It is kind of disturbing. I don't understand. What do you mean? You mean for the classroom material or just the degree program altogether? For the material, you mean for the course material? Oh, as opposed to online, if you're not online? You mean if you're in the classroom, it's different than if you're online? Or for the people who are teaching the online is different? What is different? The class material is different. So they cover different material. They don't use the same. Oh, but everybody's using the same textbook, right? Okay, so it's the same textbook. It's just a matter of what each teacher wants to concentrate on and give you more information about. Well, a lot of that is, it just depends on what area they are an expert in. Yeah, it would be great if we could be experts on everything and go over everything like experts, but we just don't have that time. You will have to be responsible for everything. But as for the sections that we go over, you know, everybody can talk about what they, you know, whatever they feel you want to talk more about. But if there's something that you want to talk more about, then yeah, you should tell the teacher, or everybody should tell them that you want to know more about this. I'm just concentrating on the overall picture and giving you then help with your assignments for your grade, and then help with your exams for your grade. As for what you wish to become, you know, a master with, that's up to you if you want to do extra stuff. Again, the programming, it's the logic that's more important. You will not have to complete programs for the midterm or final exams, and these exams are 75% of your grade. So I think I'm helping you here with the grade, but at the same time, I'm giving you a lot of the resources so you can, if you have the time, go ahead and program. Or if you have the time, you know, learn the different languages. Maybe you want to learn C, or maybe you want to, you know, learn Java. So you have that opportunity. And don't forget, even after the class is ended, you still can continue and learn more. Whatever maybe you didn't have time to learn now, go and revisit it again. You have, you know, the more you keep looking at stuff, and if you find you have a passion for something, then that's really an area that you should go into, because that means you enjoy doing it. You don't mind sitting for hours and hours at the computer learning about it. So by all means. Again, this is just an overview of operating system concepts. If there's one area you wish to learn more, then you, by all means, go for it and ask your teacher to do so. If a teacher just goes over one area, that doesn't mean that that's the only thing you need to learn. They just want you, you know, they just like discussing that material more. So that's why it's covered. Okay, but do know that everything is on the exams, not just that area that a teacher may concentrate on. So that just means that teacher likes it and wants you to know it, you know, just finds it interesting to talk about and for you to learn. So if there is anything that you want me to go over more on, that's fine too, but I'm just giving you overall, again, to help prepare you for the exams and the assignments. So, does that help you understand what's going on better? That was a long answer there. You're welcome. But you know, all your teachers are here to help you learn. And especially, there's so much to know about computers. There's so many areas. You can't learn everything in one class, no matter what. But you have to know how to learn and keep learning, even after the class is done. Because you may, things change for one thing in the computer field. They change so fast all the time. What you're going to learn here now, there's going to be new material 6 months from now that's going to be even more or a little different from what you learned. And that's okay. And if you want to keep learning it and be, you know what is new, then you have to learn on your own. You're not going to take a class every time something changes. Don't tell us. Don't tell you. Don't tell you what. Well, that's just computers in general. I know yourself. You probably had an old computer. Now you have a new computer. It's different, isn't it? That's just computers. That's how it works. And there's new operating systems coming out all the time. We're learning some of the basic operating systems, but really for all those mobile devices, like iPhones, iPads have their own operating system. Android has an operating system. Chrome is coming out with their own operating system. Now Xfinity is coming out with their own operating systems. So actually, you are in the time of history now where there is going to be so many new things coming out because everybody's working with different hardware. Remember, we have a whole revolution of new kinds of hardware so that the operating systems are going to be different. So you're in a time now that we're going over some basic stuff, but it's really going to be different, 6 months from now, a year from now, as to how all these strategies work or what strategies are the most popular. So, no, you have to keep up with that. If you want to, if you're working or you want to be, part of a company that you want to tell them or let them know what's new and coming, then you need to keep up with that. And you got to research on the internet or look at the leading professional organizations. There's a lot of professional organizations that are international, and they are the ones that usually come up with the new standards that are used in the workplace. They start doing the research and development, and then, years down the road, then it starts going into mainstream workplaces. So some of those organizations, if you are interested, but you can join them, they are international. ACM is one, IEEE is another one. These are two very important ones for computers. ACM is Association for Computing Machinery, and IEEE is for Institute for Electronic Engineer. A lot of E's there, but that's more for hardware. ACM is a lot of software, and then IEEE is for hardware. So those are two organizations. If you just go to acm.org, you can join these organizations now as a student. You get a discount, but these are the leading experts, and they set the standards, what will be used in the workplace from 5 or 10 years from now. So if you want to keep up with what's going on, you should then start going to these websites for these organizations, because then that's how you can keep learning about it. Again, you can't take a class every time it changes. And things are changing, and they're always going to change. That's just something about the computer field or information technology. They change. They always say that if you bought a computer, it's already outdated in 6 months. So that's why they have new iPhones or iPads or all those phones. They always come out with new versions. And those new versions are new operating systems or changes to the operating system because they found some new strategy that just works better. Or it's more user-friendly, so users can use it easier, or there's not so many problems. So, yeah, you have to keep up. This is one field that you have to keep current. And the best way to do that is to go to these organizations because they are the leading experts in the field. Have any of you heard of these organizations before? ACM or IEEE? Anybody? Okay, good. Then I would recommend that you go to them because then again, these are international. These are international organizations that set the standards. They're the ones that have the latest research. They're the ones that talk about the latest technology. And it's good information, and you could be a member. As a student, you get a discount, I believe. I don't know what your school offers. They may have something with your school, so maybe go through your school and find out if they have. Some of these organizations have student chapters. And these student chapters, actually, you can compete. You can do some competitions. So it helps you gather together with other students and maybe do a program project. And that's an international contest that you can enter. And then after entering the contest, you can see all the other students around, internationally around the world that are having the same interests and working on the same problems and coming up with the newest technology coming up. It's great for your reference. So it's good information for you. So I urge you to do that. Okay, I feel like I'm giving you a commercial. Commercial. Go join a student organization or international organization. You'll be that much smarter. And for the class, concentrate on your textbook. Your textbook is the main focus for the exams, and the exams are the main focus for your grade. So I'm just being simple about it and telling you how to do the best to get the best grade out of the class. And then I'll see you on Wednesday, and we'll go over more detail on Chapter 9. Make sure that you have any questions, look at the material ahead of time. So if you have questions and don't understand something, then we can go over it, or I can then give you extra resources for the discussion forum. Or if you have questions, again, put it in a discussion forum so that you can help each other out. I've noticed you've done a lot of wonderful collaboration, a lot of links. You were posting other videos that you saw, other links that you found that answered the information even better. So please keep sharing that with each other. And I will post in the discussion forum these slides. Also, I will give you a place for you to post anything you did for the Week 5 program, and then I'll have a section where you can talk about the Week 6 program. And again, I'll put these slides there that have extra links on the assignments. Okay, with that, I'm going to say have a good day or evening. If not, unless there's any more questions. Any more questions, anybody? You're quite welcome. Thank you. Okay, if you do have any more questions, don't forget we have a discussion forum. Bring them there. And I think you did well on your assignments, and then we have another wonderful week. Okay, have a nice day, and or I should say good evening. Goodbye.